Welcome back to another video. In this video, this is the second part of the last video, which was translations of the graphs of the sine and cosine functions, where we talked about how to move the graph up and down, left or right. And those were vertical and horizontal shifts. The horizontal shift is also called a phase shift. Now, in this video, we're going to talk about a combination of a lot of different translations. So we're only going to look at one example. We're going to look at one example, how to graph a function when it has multiple, a sine or a cosine function, when it has multiple different parts to it, multiple translations. And so let's jump right in and look at this example. Okay, so the textbook that I use in my class is the textbook called Trigonometry by Lyle, Hornsby, and Snyder. And in the book, it talks about two different methods to graphing these sine and cosine functions with multiple parts. However, I'm going to focus in this video on the second method that is used in that textbook. And that is when you first graph y equal a sine of b of x or y equal a cosine of b of x. And we know how to graph this because we did this in a previous video, okay? So remember, a gives you the amplitude and b changes the period. So if you remember the process that we went through to graph that, you will have to go through that process first. Once you graph that, then you will use the translations that we learned last time, the horizontal and vertical translations. You will use those to shift that graph either left, right, up, or down, however you're supposed to shift it, okay? So those are the only two steps. You just have to remember how to first graph these, okay? So let's look at this example. All right, so we want to graph y equal -1 plus 2 sine of 4x plus pi. So if you notice, there's a lot going on. We have this -1 here. Do y'all remember what -1 does to the graph? Well, if you remember, this -1 is going to shift the graph down 1 unit. So let's keep that in mind. That's going to shift the graph down 1 unit, all righty? Then we have this 2, which changes the amplitude. So that's our amplitude here. Remember that. Then we have this number that is going to change the period. However, that number has to be outside of the x, okay? I know it's next to the x, but because we have that plus pi in there, it's not considered outside of the x, okay? So what do I mean by that? Well, we need to first factor out this 4 out of this parentheses, out of this argument. We have to factor out that 4 to make it 4 times everything inside there with the x, okay? So if we factor out that 4, it's supposed to be a 4, we're left with x plus pi over 4. How do I get that? Because I divide each of these by 4. My screen is doing some weird stuff, which it has been doing for the last couple of videos. It's time for a new computer, I guess. Okay, so we're dividing both of these by 4, basically. When you divide this one by 4, the 4's cancel, you get x. When you divide pi by 4, you get pi over 4. So this actually becomes the sine of 4 times x plus pi over 4. So the first thing we want to do is we want to actually graph y equal to 2, because that's our a, sine of bx, and our b is 4 because that's the number that's being multiplied outside of the parentheses, okay? So if there's something else in here with the x that's being added or subtracted, then you have to first factor out the number that's in front of the x, because it has to be whatever the number is, b times everything in here, okay? So now the 4 is the 4 is what changes the period, and now this plus pi over 4, that's our horizontal translation. That's going to shift the graph left pi over 4 units, okay? And so let's graph this first. So remember, when we graph this, we have to find the new period. Our new period is 2 pi over b. Well, in this case, our b is 4. So that's 2 pi over 4, all righty? 2 pi over 4 reduces down to pi over 2. So that is our new period. And so now we take our new period and we break it into 4 parts. So remember, we will take our new period, pi over 2, and we will divide it by 4. Remember, when you divide fractions, you multiply, you keep change flip. So you multiply by the reciprocal, and that gives you pi over 8. So now our new points will be 0. And remember, you add pi over 8 each time because that's telling you the length of each of those intervals. Then it will be 2 pi over 8. Then it will be 3 pi over 8. And then it will be 4 pi over 8. So we start with the 0. And then we just add pi over 8 each time, 4 times, okay? And the 2 pi over 8 reduces down. That reduces down to pi over 4. 3 pi over 8 stays the same. And 4 pi over 8 reduces down to pi over 2. Alrighty, so these are the points that will go in our chart. So these are the values I'm going to plot on my first chart. So I have 2 charts here. Let's see. So yeah, and these are the x values for my first one. So 0, pi over 8, 0, pi over 8, pi over 4, 3 pi over 8, and pi over 2. Okay. Now, those are my new x values, and that comes from changing the period. Okay, so that comes from changing the period. Remember, the period changed by dividing by the 4. So the period changed to pi over 2. So instead of the graph being stretched out from 0 to 2 pi, it's just going to be from 0 to pi over 2. That's one rotation, okay? And so my y values will change by 2. Okay, so remember, in the original graph of sine, your sine of 0 is 0. Your sine of pi over 2 is 1. And then you're back at 0. Then you're at -1. Then you're back at 0. Well, you will have all those same values, except since the amplitude changes to 2, then your 1s will change to 2 and your -1s will change to -2. So at 0, remember the sign was 0. And then the next one was 1. But instead of it being 1, it'll be 2 because of this amplitude change right here. Then you're back at 0. The next number would have been -1, but since the amplitude is 2, you multiply that by 2, and that becomes -2, and then you're back at 0. And so this is the graph of your original function. So I'm just going to put these values over here. So if this is pi over, let's see, if this is pi over 8, and this is pi over 4, this is 3 pi over 2, and this is, not 3 pi over 2, 3 pi over 8. That's a 3. And this one is pi over 2. Then in black, I'm going to keep this one in black. My graph is going to be at pi over 8. I'm at 2. At pi over 4, I'm at 0. At 3 pi over 8, I'm at -2. And at pi over 2, I'm at 0. So my graph goes like this. And remember, this is the graph of, this first one is the graph of y equal to 2 sine of 4x, okay? Because that's the very first thing we have to graph in this process. We graph the a sine of bx. A is the amplitude, b, remember, is the number that changes the period. Okay, so we did that. We graphed y equal 2 sine of 4x. We found the new period. We broke it down into fourths. And so now what we want to do is we want to apply these transformations. So this transformation here that shifts the y values down 1. And this transformation here that shifts the left values, or the x values, to the left, pi over 4. So because of that, I'm going to subtract 1 from each y. So I'm going to subtract 1 from each y because of the -1. And then I'm going to subtract pi over 4 from each x, okay? So the y's are going to be the easiest. So I'm going to subtract 1. 0 minus 1 is -1. 2 minus 1 is 1. 0 minus 1 is -1. -2 minus 1 is -3. And 0 minus 1 is -1. So those are my new y values, okay? Now I'm going to subtract pi over 4 from each x. So 0 minus pi over 4 is negative pi over 4. Now pi over 8 minus pi over 4, you got to find a common denominator. Oops, that's supposed to be a pi. The common denominator is going to be 8, so multiply top and bottom by 2. And so you get pi over 8 minus 2 pi over 8. And that gives you a negative pi over 8. That's negative pi over 8. Pi over 4 minus pi over 4 is 0. 3 pi over 8 minus pi over 4 is going to give you, you'll do the same thing, find a common denominator. That's going to give you pi over 8. Because pi over 4 is equivalent, now we know it's equivalent to 2 pi over 8. So 3 pi over 8 minus 2 pi over 8 is pi over 8. And then pi over 2 minus pi over 4 is pi over 4. Alrighty, and so these are your new values. So negative pi over 8 would be here. And negative pi over 4 would be here. All right, and I'm going to switch my color so you can see the graph that we are trying to graph. I'm going to make this one red. So negative pi over 4, we're here at negative 1. At negative pi over 8, we're at 1. Oh, not that. At 1. At 0, we're at negative 1. At pi over 8, we're at negative 3, which is down here. That's negative 3, negative 2, negative 1. And then at pi over 4, we're at negative 1. And so now our graph looks like this. That would be the graph of our function. Negative 1 plus 2 sine of 4x plus pi. Okay? So we graphed the 2 sine of 4x first. And then we applied the transformations, the negative 1 and the, remember we had to factor out the 4, which made that a pi over 4. Because it was positive, it goes to the left, okay? And then I'm going to also show y'all these on the graphing calculator as well. Okay, so I'm back in desmos.com/calculator. You see the link up here in the address bar. And the first thing I'm going to show you is the graph of 2 sine 4x. And so you can check the points by clicking on them. So remember we had a point at pi over 8, 2. So up here, this should be our point pi over 8, 2. If I click on it, you see it's noted here. We also had a point at pi over 4, 0. You see that's there. We had a point at 3 pi over 8, negative 2. And then we had a point at pi over 2, 0. And we also had 0, 0. So this is one rotation or one period of that graph, okay? Now I'm going to turn on the graph with the translations. And that's the black graph. It's the negative 1 plus 2 sine of 4x plus pi. And I'm just going to cut the other one off, the green one, because it looks so confusing. But you can also check the values that we have, the new values we had on those. So we had negative pi over 4, negative 1. So negative 1 is about right here. So that should be negative pi over 4, negative 1. And it's not letting me click on it for some reason. But if you hold it, negative pi over 4 is approximately negative 0.77. I'm not exactly on it, but you can see the point that is really, really close. Negative pi over 8, 1. So that should be this point here. Yes. 0, negative 1. You can see there. Pi over 8, negative 3 is there. And then our last point was pi over 4. Pi over 4, negative 1, which is over here somewhere. And this is another one where it won't let you click, but you can get really close to it, okay? And so you can check your values on the calculator already. So that is how you would graph a cosine or a sine function that has multiple translations, that has a change in amplitude and a change in period. You will go through that process. If you have any questions whatsoever, don't hesitate to put them in the comments. Also, if this video was helpful to you, if you understood it, please hit that like button for me. And if you haven't already, go ahead and subscribe to my channel. Thank you all for tuning in and watching, and I will see you in the next video.